Okay, so last time we looked at sex chromosomes and what determines whether somebody's male or female, and that was the sex chromosomes. Remember that a nucleus has 44 autosomes, or 22 pairs of autosomes, and has a pair of sex chromosomes. And if it's a boy, the sex chromosomes are XY, and if it's a girl, the sex chromosomes are XX. So sometimes we might want to be able to look at the chromosomes and determine whether the person has the ordinary amount. Do they have 46 chromosomes, or do they have an extra or too few? Sometimes we might want to see if the person inherited an XX or an XY chromosome. And the chromosomes, of course, are in each and every cell. So if we pluck a cell out, we can't just look at the chromosomes. They're deep inside of the nucleus. And so there's a technique that we can use to make a picture of the chromosomes, a picture that looks quite like this. And this is called a karyotype. Now remember, we have 46 chromosomes, but there's really 23 pairs. And if you look, 1, 2, 3, 4, 5, right, 6, 7, 8, 9, 10, 12, 18, 19, 20, 21, 22. Those are the autosomes. There's 44 of them, or 22 pairs. And then there's sex chromosomes, either an XX or an XY. Okay, so that technique, or that picture rather, that shows all that is called a karyotype. And this is a normal karyotype. And if the person had the XX, they'd be a girl. And if they had XY, they'd be a boy. Okay, so the first thing, though, that we want to do in order to find a karyotype is we have to actually get the cell, right? You have to get a cell, and we have to get the chromosomes out of that and squash it. Look at it in a microscope. In the old days, actually look at it on the microscope and take a photograph of the picture that they saw of all the chromosomes. Now, the chromosomes aren't all neat and tidy like this. They are all over the place, right? So they'd get this photograph, and then they'd go to the dark room in the old days, right, and magnify, and develop the film, and then magnify it out, make a really large picture of this big jumble of all sorts of chromosomes everywhere. And then they would physically cut out each and every one of these and line them up and make a karyotype. And remember that these are homologous to each other. So this chromosome has genes about, say, eye color right here. And there's a gene about eye color right here. And that's true for chromosome number 1 for every human being on the planet. And if there's a gene for height on chromosome 9 over here, there's also a gene for height over on chromosome 9 here. This one came from mom, that one came from dad, right? But every single human being on chromosome number 9 has a gene for that trait right there. All right, so making the picture, the first thing that has to happen is we have to get a cell. That's pretty easy, like in an adult, right? You know, in fact, probably the easiest cells to take would be white blood cells. So you can take white blood cells. WBC stands for white blood cells. You could take the white blood cells, and you can take that cell, squash it on the microscope, take a picture, enlarge it, cut it out, arrange the chromosomes like that. Today they just do all that arranging with computers. But it's not very often that you need to see a picture like this for an adult. I mean, we can see if somebody's male or female. We can see if they have Down syndrome and have an extra chromosome. We don't really need to do a karyotype very often. There's some limited circumstances, but generally we don't. Who is it that we really need to see karyotype for? An unborn fetus. Now, in fetuses, we may want to see their karyotype. We might want to see if they have an extra number 21. They have an extra number 21, that's Down syndrome. We want to know if maybe they have trisomy 13. It's another disorder. Maybe they only have one X chromosome and no other X chromosome, or maybe they're XXY. So there's lots of different things that could possibly be chromosomal mutations, that is, things that are wrong with the chromosomes. And we might want to know that before the baby is born. And we would want to make a karyotype, but that means getting cells. And the way they do that is they do an amniocentesis. the pregnant mom, right, has her belly, and the baby's inside the uterus. And to get the cells from the baby, they take a really long needle, and they put the needle at the edge of the belly, and then push it in and push it in and push it in. They get that needle right into the amniotic sac, and they pull out some skin cells, because of course the baby's shedding skin cells just like we do all the time. They pull some of those cells out with that long needle, and then they can use those cells to make the karyotype, because those are the baby's cells. They also sometimes use a portion of the placenta. That's another option as well. That's called an amniocentesis. Often when I'm teaching this in class, my students are very alarmed at the idea of such a long needle, but they use sonograms so that they can see where the needle is going, so that they know they don't hit the baby. And it's got a very low rate of side effects or unintended consequences. And sometimes students are worried that it hurts. I know my mother, when she was pregnant with me, had an amniocentesis. They were concerned about me because my mother's blood and my blood didn't match, and there were some issues with that. And so my mother described it. So she had that done in 1967 when she was pregnant with me. And she said that she felt so much pressure on her belly that it really was almost numb, and it really didn't bother her. I never had an amniocentesis, so I can't speak to that. Okay, so once you get the cell, you have to take get the nucleus of the cell and squash it on the slide. And then you can get that view. It's a bunch of chromosomes everywhere. You see that on the microscope. You take a photograph, you enlarge the photograph, and then you cut out the chromosomes and pair them up like this. Now, I'm not trained to do karyotyping. I couldn't possibly decide whether something was chromosome, let's say 7 or 6. Those look really close to me. I'd have a really hard time figuring out which one was which. Look at 20 and 19. I mean, I'd have a really hard time figuring that out, but there are people who are trained to do that really well. You're going to do a little activity after this with those. Now, what happens if we get an extra? So sometimes we might have an extra number 21 or number 13. How does that happen? Well, remember, during meiosis, we split apart the homologous pairs, right? And each egg gets 1/2 of each pair. So an egg will get either this chromosome or that one. The egg will either get this one or that one. The egg will get one of each one of these, right? Get one of all of the 22 pairs of autosomes and get one of the sex chromosomes. The other eggs will get the other half. Sometimes the chromosomes don't separate. They don't do disjunction. They don't come apart. And an egg might end up with 2 number 1s. If the egg ends up with 2 number 1s and a sperm has a number 1, the baby will end up with 3. And that's how you get an extra chromosome. It's called nondisjunction. That happens during meiosis, during the making of sperm and egg. Down syndrome, you get an extra, that little one, number 21. Turner syndrome. Turner syndrome is when you get only one X, and the other egg or sperm doesn't have a sex chromosome. And then there's Klinefelters, and Klinefelters is when the baby gets an X and a Y. It's a boy, and generally developmentally disabled.